All right, guys, let's talk a little bit about math and significant figures. This is a big part of reporting answers that you might be calculating with the right number of significant figures. And that has everything to do with rounding. And you guys are pretty familiar with rounding. You've probably been doing it your whole academic career. And so I think some of the things are pretty basic for you, but we're gonna do some practice with rounding here just to begin with to make sure that we are all on the same page, okay? So I got the sheet of work here, and let's start with a few of these really easy ones, and I'm sure you guys are gonna fly through this. So if we wanted to round these numbers to the nearest whole number, that would be something that you've done probably your whole life. So 3.3, if you were rounding that, this would be 3, right? Remember the rule is if the decimal place is a 5 or above, then you round up, and if it's below 5, you round down, right? So 4.7 rounds up to 5, 9.5 rounds up to 10, and 6.8 rounds up to 7, right? That is pretty routine for people, all right? Now, I want to review significant figures here because we got to make sure that we really know how to count significant figures. That leads us into how to round correctly to the right number of significant figures. So let's again just review decimal place present versus decimal place absent in a couple of these numbers. So our first one here, we've got our decimal place. That means we start counting from the Pacific or present side of the number. We start counting at the first number that's not a 0. That's that 5 right there. And once we start counting, we do not stop counting, right? So this number has 6 significant figures, all right? On the other hand, when we have a number that does not have a decimal place, we begin counting at the Atlantic side of the number, the absent side, and we follow the same rule. We start counting at the first number that's not a 0, and then just count all the way through. So the first number that's not a 0 is the 8, and we count all the way through to the front of the number, and this number has 3 significant figures, okay? Now when you read a number, you know, when you're counting, especially with these guys without a decimal, the first number that you would count would be the 8, but that is not the first significant number. Really, remember that you read a number from left to right, whether it's got a decimal or not. The process of counting from one side or the other is just to determine the number of significant figures in the entire number. But really, remember, the number reads from left to right no matter what. Okay, so with that in mind, let's do some practice rounding some numbers to the appropriate number of significant figures. So here's a big long number with a decimal, and we're going to round this to 1 significant figure. And knowing that we read a number, whether we count it from the left or from the right, we read a number from left to right, right? And so the first number that we find that is significant in this number with a decimal is the 5. So just like up here, you just have to look to the next number in line to see if there's any change to the 5. And there is, right? That 6 is going to round that 5 up to a 6. And so here, the number reported as 1 sig fig is 6, right? Pretty close to 5.6, but we've just now put it into rounded to 1 significant figure. Okay, how about this one? Here's another one. This is 0.04102. We want to round that to 3 significant figures. So our first significant figure as we read from left to right is our 4. And then the 1 and the 0 and the 2, these are all significant, but we can only report 3 sig figs. So there's the cutoff for our 3 sig figs between the 0 and the 2. How does the 2 affect the 0? It doesn't. So this number reported in 3 sig figs is 0.0410. All right, next in line is 2.998 rounded to 2 significant figures. So we just have to see how the second significant figure affects the first. The 9 rounds the 2 up to a 3. 3 is not an appropriate answer here because we need two significant figures. This is 3.0. Okay. Here's 26,384. Let's round that to two significant figures. So, you know, all of these numbers are significant reading from left to right. Our two significant figures are the 2 and the 6 right here. So we just have to see how the third number affects the second. That 3 is not enough to round up, so this is 26,000. All right. Here we go, 37.446. We want to report that with three significant figures. So there's our three significant figures, right? 37.4. We just have to see how that fourth number affects the third. And the 4 is not enough to bring that first 4 up to a 5, so this is 37.4. All right. A couple more of these and then I think we'll be pretty well dialed here. 49.0385, let's go to three significant figures, and there's your numbers, right? 49.0, those are the first three sig figs. How does that 3 after the 0 affect it? Well, it doesn't. This is going to be 49.0. All right. And then how about this one? Oh, here's a good one. 0.00794. We only can report one significant figure here. The first significant figure we come to is the 7, of course, reading from left to right. And so that 7, how does the 9 affect the 7? Well, it turns it into an 8, right? So this is 0.008. You know, it's three numbers, but only that 8 is the significant number according to the way that we count these things. Here's another one. Let's do just a few more. We want to take this number and round it to three significant figures. So the first significant figure you come to is the 6, and then those zeros are significant. So there's your three numbers that you want to report. How does that next number affect that second 0? That 8 is enough to bump that 0 to a 1, and so this is 0.00601. Make sense? I think you guys kind of have the picture. Now that you do have the picture, we can start talking a bit more about why rounding is so important to what we do here in chemistry. A lot of the calculations that you're going to do, you have to round your answers in just the right way, and that's what we're going to talk about here. Okay, so most of the calculations we make in chemistry are just one of our four basic calculations of either multiplication, division, addition, or subtraction. And so when we're multiplying and dividing numbers, we have to follow certain rules, okay? So let's just talk a real world example here. So let's talk about density. Density is just a calculation where you divide the mass of something over the volume of that thing. So I don't know, here's just some kind of numbers out of nowhere. Let's just say that someone puts something on the scale and it is 4.213 grams, okay? And then maybe they do like a water displacement thing where they put the object in a graduated cylinder and measure the change in the water level. Anyway, let's just say that this volume is 6.82, okay? That would be milliliters, so mass over volume. And let's go ahead and divide those numbers. 4.213 divided by 6.82. Okay, so this is what you get on your calculator. I'll zoom in on that. So the question is always like, what do you want us to round our answer to? Because, you know, that's the question that really matters here in chemistry. And so this number that comes up on the calculator, 0.617741935, that is not the appropriate answer. That is not going to get you credit on a test question or something like that. You can't report this. The rule here, when you're multiplying or dividing two measured numbers, you have to look at the numbers that you're working with, and then you have to round your final answer to the lowest number of significant figures from the number in the problem. Okay, so this number here is 3 significant figures, and this number here is 4 significant figures. So you have to just see which of the two numbers has the least number of sig figs, and then round your final answer to that number of sig figs. And so that's why we got to be good at rounding. So our final answer here is going to be 0.618, right? We've isolated our 3 sig figs here, and we've seen how that next number affects the third number. That second 7 bumps that first 7 up to an 8. And that is your final answer. That is the correct answer. So we would say grams per milliliter as a unit, and that's your answer. And the reason we do this is because we're basing the final answer on the precision of the least precise measuring tool. So we can see here that our scale, which is more precise than the graduated cylinder we're using. Remember, the scale is precise up to the hundredths place, and the graduated cylinder must be only accurate up to the tenths place. So we have to round our answer based on the lowest precision tool that we have to use. And the same would be true if you were multiplying two numbers. This was a division example, but if you multiplied these two numbers, you would have to do the same sort of rounding, okay? Counted numbers are a little bit different here. We work with counted numbers quite a bit, I guess, but counted numbers have infinite significant figures. That means that we don't have to follow this rule if you are multiplying and dividing with counted numbers, okay? Now, the other kind of family of math stuff that we would do is addition and subtraction, and they follow a slightly different rule. So let's just add up these numbers and see what we get here. So 3.5 plus 2.75 plus 4.824. Okay, that gives us this number here, 11.074. All right, so the rule for these guys is a bit different. It's not limited to the least amount of significant figures, which in this case would be 2 right here from the 3.5. We don't do that here with addition and subtraction. Instead, what we do is follow the decimal place rule. So the decimal place rule just basically means that your answer is limited to the least amount of decimal places, not significant figures. So we're not counting up significant figures, we're just looking at decimal places. So here, obviously we only have 1 decimal place here, 2 decimal places here, and 3 down here. That means that we can only include the first of our decimal places in the answer. But you've got to still make sure you're rounding. Like, how does that 7 affect that 0? Well, it changes it, right? And your final answer, your reported correct answer, is 11.1. All right? So even though this is 3 significant figures, that doesn't matter. What we care about in addition and subtraction is the number of decimal places that there are in the lowest amount of decimal places from the numbers in the problem, okay? So I hope that helps, and I hope that makes sense for these rules for significant figures, adding, subtracting, multiplying, and rounding.